Okay, so today's lesson is an extension of what we did yesterday on elimination. But today, if you notice, when we look at our system of equations, I don't have anything that is alike or different. So 2, hang on a second, my 2x and my 3x, they are not the same or opposites. My y and my 2y are also not the same or opposites. So what we have to do in this case is we have to create these terms. So we have to make them the same or opposites. And this is one where you have a little bit of freedom as well. You can choose to get your x's to be the same, or you can choose to get your y's the same. Now, depending on what you choose, you may create a little more work for yourself. So this is another example where we work smarter, not harder. So what I like to look for is there a variable that does not have a coefficient in front of it? Meaning, is that number in front of the variable just 1? So if that's the case, that's the one I'm going to make look like the other term. So we ask ourselves, okay, my other y term has a 2 in front of it. So what do I need to do to my 1 to get a 2? And what we do to it is we have to multiply by 2. But we're not allowed to just multiply one term by 2 because then that would change our equation. What we have to do is multiply every single term in the numerator by 2. Now, I prefer to also put the 2 on the right-hand side because I know myself and I know that sometimes I forget to distribute it all the way over there. So if I put this 2 over here, it sort of reminds me to distribute to there. So hang on, So I'm going to take my top equation and distribute the 2. So 2 times 2x is 4x. 2 times 1y is plus 2y. 2 times 23 is 46. And then I'm just going to write my other equation down as it is underneath of it. And then if we look, we can say, oh, okay, I now created the problem we had yesterday. So this problem here is exactly what we had yesterday. I now have 2 numbers that are the same. So if they are the same, just like yesterday, we subtract. So I know I told some of you yesterday I prefer to distribute that negative sign to everything so that way I don't forget. So 4x minus 3x is 1x. 2y minus 2y, that cancels. And then 46 minus 37 is 11. So I don't really need the 1 in front of the x, so we already found x. X is 11. So just like yesterday now, I have to substitute this back in. I'm going to put it into the top one because I feel like that is the easiest to solve for y. So when I substitute that back in for x, I get 2 times 11 plus y equals 23. So 22 plus y equals 23. Subtract 22 from both sides. We get y is equal to 1. So don't forget, the solution to a system of equations is an ordered pair. So 11, 1 is our answer. Okay, so after this first step of multiplying, the problem is just like what we did yesterday. So pause the video now, try to do this your turn on your own, and then once you either get finished or you get stuck, come back and see what I'm doing here. All right, so for this one, these two, I see my x only has a 1 in front of it, so that's what I'm going to multiply by. And to make this 1 become a 3, I need to multiply by 3. So once I do that, 3 times 1x is 3x, plus 3 times 7y is 21y, equals 3 times 12 is 36. The bottom equation, we take 3x minus 5y equals 10. And then we look and we say, okay, these are the same. And when they are the same, we subtract. So 3x minus 3x, that's 0x. Look here. I have minus and negative, so that really makes it a plus now. So now I have 21 plus 5, which is 26y, equals 36 minus 10, that's 26. Divide both sides by 26. We get y is equal to 1. Just like before, substitute it back in. I'm going to choose the top equation. I think it looks a little bit easier. So x plus 7y equals 12. Our y we just found was 1, so substitute that back in. So x plus 7 equals 12. Subtract 7 from both sides. X is equal to 5. Don't forget your final answer, 5, 1. Okay? All right, are we ready for example 2 now? This is the only other thing they can do to you. So now if you're looking at these two equations, you probably notice every single x or y has a number in front of it. All of them. So you pick your favorite. I generally try to pick the variable that has the smaller numbers in front of it. So 3 and 4 is just a little bit less than 3 and 5. So what I'm going to do for this one is I'm going to get my x numbers to be the same. So the easiest thing you can do to get them to be the same is just multiply them together. So since my top equation is a 4 and my bottom one's a 3, I'm going to multiply my top equation by 3. And since my bottom equation is a 3 and my top one was a 4, I'm now going to multiply that one by 4. So basically it's just like we're multiplying them together. But now I have to rewrite both equations. So if I distribute my 3, I get a 12x plus 9y equals 24. And in my denominator, I'm going to get a 12x, a minus 20y, and then negative 23 times 4 is negative 92. Okay, don't forget, use your calculator. Now we say, okay, my x terms are the same, so when they are the same, we subtract. So what that subtraction does, it makes both of those negatives positives. So 12 minus 12 cancels. 9 plus 20 is 29y. And then 92 plus 24 is 116. To get y by itself, we divide both sides by 29. And we get y is 4. So again, halfway done. Once we get to this step, it's just like what you did yesterday. So now pick your favorite equation. I'm going to pick the top just because everything is positive. So now it's 4x plus 3 times 4, because we just found that y was 4, equals 8. So 4x plus 12 equals 8. Subtract 12 from both sides. 4x equals negative 4. Divide both sides by 4. Sorry, I didn't show that. We get x is negative 1. So my ordered pair is negative 1, 4. I know we're getting a lot of 1s. You're not always going to get a 1. All right, so again, pause the video. I'm not going to explain this. I'm just going to go through the work. So you guys pause the video, try it on your own, then come back. Actually, I'll plug it into the bottom one this time. Now, the other thing I should have said, don't forget, you can always check this. We've discussed this before. To check it, you simply plug 4 in for your x, your -1 in for y, and make sure, does the left side equal 10 for the top equation? Does the left side equal 3 for the bottom equation? And they both must be true in order for it to be a solution. All right, the last two here are your favorite word problems. So the first one, they gave us 4 options. I'm actually going to ignore those options and try writing them myself and then just matching them up, because sometimes I feel like we get ourselves a little bit confused if we have too many options. So we're just going to ignore them for now. So let me just cover them up. Okay, I'll try to remember to write below them. All right, so it says John has 30 science fiction and mystery books. 4 times the number of science fiction books minus the number of mystery books is 5. Which system of equations can be used to find how many science fiction, F, and mystery, M, books he has? So I see a couple things here. He has 30 books total. Okay, science fiction, which they said was F, and mystery, which they said was M. So that's my first equation. Hang on a second, I wanted to write it below. F plus M equals 30. He has 30 total books. The next equation, it says 4 times the number of science fiction books. So 4F minus the number of mystery books. So minus mystery is 5. So that's equals 5. There's my 2 equations. So let's erase all that. All right, so A here, the top is right, but the bottom's wrong. So that's not it. B, F plus M equals 30. That matches. 4F minus M equals 5. That one looks like it's right. But let's double check. The next one, no, because it has an addition sign. And the last one's not right because they both say F plus M. All right, so take a moment, try this last one. Again, pause the video, try it, come back. All right, so Suzanne has 50 stamps. 2 times the number of flower stamps plus the number of cartoon stamps is 70. Which system of equations can be used to find how many flower stamps, F, and cartoon stamps, C, she has? So they didn't give us the options, or they did, and I deleted them so we could do our own. So she has 50 total stamps. We know her stamps are made up of flower and cartoon. So we have F plus C equals 50. We don't know how many of each. We just know that if I combine them together, there's 50 total. The next part says 2 times the number of flower stamps. So that's 2F. Now it says plus, so we have to put a plus down. The number of cartoon stamps is 70. So cartoon is 70. Okay. So then we're just going to go ahead and solve this. Didn't really ask us to. I don't think which system can be used to find, but we're going to find them. So I'm just going to go ahead and subtract because I noticed that my C's were the same. So we're subtracting. So 1F minus 2F is negative 1F equals negative 20. So F is equal to positive 20. So if she has 20 flower stamps, 20 flower stamps plus cartoon stamps equals 50. So subtract 20 from both sides. That leaves us with 30 cartoon stamps. All right, so your practice work, I'm almost certain I chose this page, and I think I chose actually all of it, I think, 1 through 14. So not all of it, I should say, but 1 through 14. Now, one thing I will say, 1 through 11, you're going to use the method we used today. 13 through 17, you can use any method. So I know some of you said this was your favorite method. Others of you said no, you prefer substitution. And I believe one sole person said they really liked graphing, so you may use any method you want for 12 through 17.